Welcome. Today, we are going to go into an adventure, and we're going to be dealing with forces of good and evil, and when they attack, a resultant force will happen. Let's see, what are vectors? Let's so, as we go into the world of Despicable Me to find out more about vectors.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
And so now, we will talk about vectors. Vectors are measured in direction and magnitude. Magnitude is the length of a line segment. You can use the Pythagorean Theorem to find the length. You can use the distance formula to find the length. Magnitude. An example. Here's an example of the magnitude. You've got the point 42 for y and z is 2,8. We found the magnitude by doing the distance formula. We took and plugged in the values and simplified and got 2 root 10 for the magnitude. Then we could also do the Pythagorean Theorem. You see the triangle. The length of the base is 2, the height is 6. Again, 2 squared plus 6 squared is equal to x squared. We simplified and we got 2 root 10. What is direction? The direction of the vector is directed angle between the positive x-axis and the vector. That's the vector. That's direction. That's the x-axis. Use sine, cosine, and tangent ratios to find the direction. Now we will check out a toddler pulling a dog in a wagon because this uses forces.
Good job. Pull, Alex. Bye. See you guys later. See you later, alligator. Scout rides in wagon. Good job turning.
Wait.
Now we'll talk about Belky pulling a toy by exerting a force of 1.5 newtons on a string attached to the toy. The string makes an angle of 52 degrees with the floor. Find the vertical and horizontal components of the force. If Belky's raises the string so that it makes a 78-degree angle with the floor, what are the magnitudes of the horizontal and vertical components? I don't know. Let's find out with a video explanation.
All right, I'm going to explain this little situation with Belky and the little toy that's being pulled, okay? So, this is number 40, page 491 in your book, all righty? So, here we go. Belky is pulling a toy exerted by a force of 1.5 newtons on a string attached to the toy. So, here's Belky. Here's toy. Okay, and the string makes an angle of 52 degrees to the ground, so this is 52 degrees. Here is clearly the ground, okay? This is the force. It says the force here would be 1.5 newtons, all right? And it's asking for the horizontal and vertical, of course, I guess I should put Y here and X here, horizontal and vertical components. Okay, well, this is using trig. All right, beginning of the year stuff here. So we're going to say opposite over hypotenuse is sine. So sine of y is equal to, sine of 52, excuse me, whoopsie, don't error. Sine 52 is equal to opposite over hypotenuse. All right, so then we do 1.5 sine 52. All right, and that will give us the answer, and I'll tell you that in a minute. Let's go ahead and do the next thing. I'll use the calculator at the same time. Let's go ahead and say this would be the y value, okay? And now let's do the x value. Well, that would be adjacent over hypotenuse. So cosine of 52 degrees is equal to adjacent, which is x, over hypotenuse, which is 1.5. So 1.5 cosine 52 is equal to x. Okay, Ken, we'll just use a calculator and get these answers. And now I have to use the calculator. Bummer. I'll pause the video. Okay, so typing in the calculator, got 1.18 newtons is the vertical, the y, and 0.92 newtons is the horizontal. These are the two components. Okay, now looking at part B, it says same situation, but this time, all right, this time Belky raises the string so that it's 78 degrees with the floor. So instead of 52, here we have 78 degrees. Okay, and what are the magnitudes of the horizontal and vertical? Okay, so the same number of newtons, 1.5 newtons. So you're going to do the exact same thing as what we did before. Instead of 52, though, you're going to have 78. That's the only thing that changed, so that's the only change in this. Okay, so we're still going to do sine is opposite of y over 1.5, but instead of the other, this is now 78. And this is now 78. And again, typing this in, you should get the two values of 0.31 newtons and 1.47 newtons. Okay, and these are the two components. So this is how you do this problem.
All right, now we're going to look at car crashes and how they are affected by vectors.
Get through that, McQueen! A huge crash behind the leader. Wait a second, Darryl. McQueen is in the wreckage.
There's no way the rookie can make it through. Not in one piece, that is. Look at that! McQueen made it through.
All right, so here's Police Officer Patricia Malloy is investigating an automobile accident. A car slid off an icy road at 40-degree angle with the center line of the road with an initial velocity of 47 miles per hour, using the drawing to determine the initial horizontal and vertical components of the car's velocity. And we'll do a video explanation.
All right, here's the situation. We have this car skidding off the road at 47 miles per hour and at an angle of 40 degrees from the horizontal or the vertical in this situation. And draw the triangle. We can still use sine and cosine. So sine of 40 degrees is opposite over hypotenuse, so x over 47. Cosine of 40 degrees is adjacent over hypotenuse, y over 47. Solve these the way we did the last problem, and you'll get that the x is 30 miles per hour and the y is 30 miles per hour. There you go. That's it.
All right, now we're off to yet another type of situation. This is coming back from some fun heroes I watched as a kid. Masuko, total common name, has attached 2 wires to a corner fence post to complex a horse paddock. The wires make an angle of 90 degrees with each other. If each wire pulls on the post with a force of 50 pounds, what is the resultant force acting on the pole? You can see that the 50 pounds is along the horizontal, the 50 pounds is along the vertical, and the resultant is the hypotenuse. All right, guys, try first. Don't think I'll just give you the answer, because I won't. Figure it out. You can do it. That's right. I'm waiting on you. Get that calculator out. Come on, you can guess. I know you can. All right, are you ready for the answer? The answer is 71 pounds. And if you got that, congratulations. And the crowd is going wild. Yay! So proud of you. All right, now we need a moment for comic relief because there's just too much. So here's the comic relief video. Yay! All right, and now we're back to our normal proceeding show, vectors. To find magnitude of a 3D vector, just use the distance formula with 3 dimensions. For example, 2 and 3 of lesson 8.3, page 501. You will see it shows the distance formula, and you will see how it actually found the vector xy. Notice that to find the vector xy, you take the y values minus the x values. That's right. You take the last and subtract the first. You will see that done in example 2. Then you find the magnitude by doing the distance formula. You will take this -1 squared plus the -2 squared plus the 4 squared because we just found the differences. Let's look at an example. All right, here's an example. 16. T is -2, 4, and 7. M is -3, 5, and 2. First, let's find the vector. We took -3 minus a -2, 5 minus a 4. And it should have been, yes, and it's 2 minus 7. That's right. And that gave us -1, 1, and -5. This is the vector. Now let's find the magnitude. Notice I didn't have to do it again. I could just use these values. This -1 squared plus 1 squared plus a -5 squared, and I took the square root of it. That gave us the square root of 27, which can be broken down to the square root of 9 times the square root of 3, which is 3 square root of 3. Yes, we've just done three-dimensional vectors. All right, for extra credit, and you made it to the end of this video, Send a picture of your best villain or hero costume. Post it on Google Classroom Stream. Then we'll find a way to vote. Any ideas on how we can? Let me know. All right, have a great time. I hope you enjoyed the video.